Hello, this is Chase Ray.
And this is Chima Chukwemeka from Tennessee Tech University. This video is for Dr. Stress's Advanced Thermodynamics class, and we want to talk about the pasteurization of orange juice.
The main message we are trying to convey is when you apply elevated heat to a liquid product, in this case orange juice, it causes a decrease in its entropy, thereby producing a product with a reduced microbial load.
There are a plethora of liquid food products out there in the market today, and all these liquid foods have issues when it comes to their shelf life. Trying to alleviate these issues is where engineers come into play. One way of extending the shelf life is by pasteurization, and some of these pasteurization processes involve exchange of energy in some fashion.
What is pasteurization exactly? Well, it is an engineering process that involves treatment, albeit by heat or another means, of liquid foods for a certain period to attain a desired quality. The overall objective of the process is to inactivate enzymes and reduce the growth of spoilage microorganisms in liquid foods, thereby extending product shelf life.
Heat pasteurization can be done using two different methods: low temperature high time and high temperature short time. And as these names suggest, this process is simply heating orange juice to a desired temperature for a certain period and then followed by immediate cooling. The quality of orange juice is very sensitive to the time at which the process occurs. If the orange juice were held at a lower temperature for an insufficient amount of time, the orange juice would be under-pasteurized, which leads to insufficient inactivation of enzymes and a product still with spoilage microorganisms. On the other hand, if the orange juice were held at a high temperature for an exceedingly amount of time, it is said to be over-pasteurized, and this results to degradation of the quality of orange juice, which would be unpleasant to ingest. In manufacturing orange juice, first, oranges are processed and juiced. Secondly, it is pasteurized. Then, it is refrigerated prior to packaging.
What governs heat pasteurization process, you might ask? Well, according to Wahid and others in their paper titled Energetic Analysis of Fruit Juice Processing Operations in Nigeria, which was an energy and exergy study conducted in an orange juice manufacturing plant. They report that the pasteurization process can be looked at from an exergy perspective. The exergy of a flow crossing the system boundaries of an open system can be written as. The last term of this equation takes into account of the contribution due to the chemical transformation of the system. This term is neglected in this study because the processes involved no chemical reaction. The exergy difference delta E sub x between the outgoing and incoming streams for a steady flow process is defined as, where W is the useful work, R the production of entropy, and T the ambient temperature. From this equation, it can be seen that the exergy change is a balance of useful work and the entropy production term, which can be regarded as work loss because of irreversibilities. For a reversible process, R equals 0, and thus the exergy change of a reversible process equals to most the useful work associated with a work-producing process or the least useful work required by a work-consuming process. It is evident from the foregoing that the exergy change and the creation of entropy are the energy bounds of the process. Exergy studies allows a system to be analyzed more comprehensively by determining where in the system the exergy is destroyed by internal irreversibility and its causes. Inefficiency can be defined as the ratio of the irreversibility in each section to the irreversibility over all sections. This is defined mathematically as, for the plant in this study, there was 90% inefficiency in the pasteurizer, which compared very well to a tomato paste production plant with 68% inefficiency. The high exergy destruction in the pasteurizer may be reduced by an increase in the capacity of the holding tank, which will result in the reduction of the load on the boiler. Another way to reduce the high exergy destruction in the pasteurizer is by the introduction of the heat integration between the pasteurizer and the packaging units. Heat integration for minimum utilities consumption corresponds to minimum production of entropy as well as to minimum ideal work given by the process utility stream. In conclusion, the major exergy loss took place at the pasteurizer with an inefficiency of 90%. This was a result of the use of steam for the heating of the process stream. One method of improving the thermodynamic performance of the plant is by the use of process heat integration.
With heat pasteurization being so predominant in food industry, many regulatory agencies have recognized its importance and endorsed its impact on preventing food spoilage. According to United States Food and Drug Administration in 2001, heat pasteurization presents a 5-log reduction in the most resistant food spoilage microorganisms. This is simply a log scale, and the orange juice must be kept in the heat long enough to get a 5-log reduction in the amount of microorganisms present, as shown by the table and graph.
Although thermal pasteurization is effective in preserving foods, other processes such as pulse electric field pasteurization has been developed and also gained glowing reviews. It involves sending pulses of high voltage through foods placed in between two electrodes, which causes microbial inactivation, and has been shown to be more effective in retaining greater organoleptic properties in the orange juice, such as color, taste, and texture.
According to research, the pulse electric field treated orange juice was shown to have greater amounts of vitamin C, the 5 flavor compounds, and better color than the heat pasteurization. However, heat pasteurization and pulse electric field pasteurization successfully inactivated spoilage microorganisms. Furthermore, loss of flavor compounds occurred in both processes.
And now we would like to thank you for your time for watching our video. We would like to acknowledge Dr. Stretz for in-depth knowledge of the subject and many other sources from which we gain the information.